Hello everyone. In this lesson we're going to take a look at inscribed angles. Here we can see an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and whose sides intersect the circle. We can see that there's an arc here between the ends of the angle, and this arc here that I'm highlighting in blue is called the intercepted arc. What's the relationship between the measure of the inscribed angle and the intercepted arc? Let's find out. Here I have a diagram. I have a diameter and a radius. And notice I've marked my radii to be congruent. Let's say that the measure of this central angle is x. That would mean that the measure of this arc here would also be x. Next, let's think about the measures of the angles in the isosceles triangle. This triangle is isosceles because the radii in that circle are congruent. And because the triangle is isosceles, I know the base angles are congruent. Then I remember that the exterior angle of a triangle is equal to the sum of the two remote interior angles. So in other words, these two angles need to add to x, but they also need to be congruent. That means that each of these angles must have a measure of x over 2. So that means that the measure of this inscribed angle here, which I'm going to highlight in purple, the measure of this inscribed angle is x over 2, and the measure of its intercepted arc here is x. So if the vertex of an angle is on a circle, in other words, if we have an inscribed angle, then the measure of the angle is half the measure of its intercepted arc. Let's take a look at some corollaries that follow from this. Corollary 1, if two inscribed angles intercept the same arc, so this inscribed angle, let's say that this is maybe 20 degrees, that would mean that this arc would have to be 40, but then this blue angle is also intercepting that same purple arc, so that means that this angle would also have to be 20. So if two inscribed angles intercept the same arc, then those two angles are congruent. Let's take a look at another corollary. Here we have a semicircle. We have actually two semicircles because we have a diameter here. An angle inscribed in a semicircle. Let me see, I'll draw an angle here. So that's my inscribed angle. What would the measure of this angle be? Well, this intercepted arc here is a semicircle, and I know a semicircle is 180 degrees. So that means that this angle would be 90 degrees. Even if I drew my inscribed angle here, or I drew it here, or I drew it over here, it doesn't matter as long as the endpoints are on the ends of a diameter. If my angle has its endpoints on the ends of a diameter. All of these angles are intercepting a semicircle, a 180 degree angle. That means all these angles would be 90 degrees. That would make them right angles. So corollary 2 says an angle inscribed in a semicircle is a right angle. Let's take a look at one last corollary. It's actually further down this page here. So it says if a quadrilateral is inscribed in a circle, then the opposite angles are blank. Let's think about this a second. Let me get a quadrilateral inscribed inside this semicircle, or excuse me, inscribed inside this circle here. So let's just think about this for a second. Let's say that this, let's say that this angle here is x, and this angle here is y. Those would be the opposite angles. Let me change the color here to be red so that this will stand out a little more. So my angle that I have labeled x, its intercepted arc is this one here. And we know that the angle is half of the arc. So this blue arc would be 2x. And the angle that I've labeled y has this arc as its intercepted arc. So if this angle is y, I know the arc is 2y. Once again, the angle's half the arc. Well, if I think about this for a second, I know that 2x plus 2y must add to 360 because a full circle is 360 degrees. And if 2x plus 2y adds to 360, that means x plus y adds to 180. And two angles whose measures sum to 180 are supplementary. So if a quadrilateral is inscribed inside a circle, then the opposite angles are supplementary. Please don't forget to do the survey at tinyurl, and we'll look at the results in class.